In the last video, we have seen the working of relational and the logical operators. In this video, we will see how to use various bitwise operators that are supported by Python. So, Python basically supports various bitwise operators like NOT, AND, OR, XOR, left shift and the right shift. So, these operators work on the binary representation of the given operands. That is why these operators are known as a bitwise operators. These operators can be used only with the numerical data, especially with the integer data. These operators cannot be used with the float type of data or the complex type of data. These operators even cannot be used with the sequential or other type of data. So, these operators can be used only with the integer and the Boolean type of data. Now, let us see the working of each of these operators in detail. So, let us consider two integer variables x and y. So, x is assigned with the value of 8 and y is assigned with the value of 9. Now, I am going to apply the bitwise OR operation on these variables x and y. So, x or y, and similarly I am going to apply the bitwise AND operation on the same variables, and I am going to apply the bitwise XOR operation on x and y. So, here you can see the bitwise OR operation returns 9, AND operation returns 8 and the XOR operation returns a 1. So, as a result of these bitwise operations, the values returned are of type integer. But how the operations internally work is, but these bitwise operations work on the binary representation of these operands. So, that is, first x is converted to binary representation and similarly y is also converted to the binary representation, and then the bitwise OR operation will be applied, and then the resultant binary representation will be converted back to the integer representation, and that integer value will be returned as a result of the bitwise operations. So, if you want to check how this operation is working, so convert these numbers to the binary representation. You can use the bin method to check the binary representation of any integer. Here I am passing the variable x to the method bin to check the binary representation of this variable x. So, here you can see this is the binary representation of x. So, similarly you can see the binary representation of y by passing y to the bin method. So, here you can see the binary representation of y. So, this is the binary representation of the bitwise XOR operation on x and y. The bitwise operation will be applied on the corresponding bits of x and y, and the resultant value will be returned in the form of the binary representation. The bitwise OR operation returns a 1 value when either of the bits is a 1, and when both the bits are 0, then only it returns a 0. Here if you observe, both the corresponding bits are 1, so it is returning a 1, and in this case either of these bits are 1, so it is returning a 1. So, that is how you can see how the bitwise operations work internally. But again, this value is returned back to the integer representation, and then you will be getting the result. That is how when you are applying the bitwise OR operation on these variables, you are getting an integer value as a result. The same thing is applicable for all the bitwise operators, not only for the OR, that is applicable to bitwise AND and the bitwise XOR operations. So, here you can see this is the binary representation of x, the binary representation of y and the binary representation of the x and y. The bitwise AND operator returns a 1 when both the corresponding bits are 1, in the other cases it returns a 0. So, here you can observe that. So, here in all the 3 cases, so either of the bits are 0, so it is returning a 0. But whereas in this case both the corresponding bits are 1, so it is returning a value 1. 1 0 0 0 as the output, but it returns the integer equivalent to that binary representation, which is 8. Now, let us see the working of the XOR operation on the variables x and y. Here you can see the binary representation of x and the binary representation of y, and the binary representation of the XOR operation on x and y. So, how this XOR operation works is, when the corresponding bits in either of these operands is a 1, then the XOR operation will result in a 1 in the corresponding location, otherwise it results in a 0. That is, when the bits in these operands are the same, then the XOR operation will be resulting a 0, otherwise it results in a 1. Here if you observe, so in the rightmost bit, so in x there is a 0 and in y there is a 1. So, they are different, that is how it is resulting in a 1 value in the XOR operation, whereas in the other bit locations, the bits are the same in both the operands x and y. So that's why it's resulting in a 0. This binary representation will be converted to the decimal form, and then the XOR operation will result in the decimal representation of the integer numbers. So that's how the bitwise XOR operation works in Python. So now let's see how the bitwise NOT operator works in Python. So this NOT operator, you can use this symbol for the NOT operation, so which stands for the complement operation. So this is the unary operator. It takes only one operand. So I am applying this bitwise NOT operator on the variable x. So when I apply it on x, the resultant value is a -9. So how it works is, if you observe the binary representation of x, so it flips all the bits in x. So if it is a 1, then it flips to 0. If it is a 0, then it flips to 1. And so here the x value is 8. So you can consider the result of the bitwise NOT operation as minus of that operand value plus 1. So here x value is 8. That's how we are getting minus of 8 plus 1, that is -9. So that's how the resultant value of this bitwise NOT operation is a -9. So far we have seen various bitwise operators like bitwise OR, bitwise AND, bitwise XOR and bitwise complement operators. So in addition to these bitwise operators, Python also supports two additional bitwise operators for shifting. So it supports the bitwise right shift and the bitwise left shift operators. So these two are again the binary operators which takes two operands. So here I am applying bitwise right shift operator on the variable x. How this operator works is, it takes two operands and it shifts the bits in the leftmost operand for specific number of times. And how many number of bits it shifts is denoted by the right side operand. Say for example, here in this case, consider this example, x right shift 2. That means here 2 bits of the binary representation of x will be shifted towards right. Here you can see, so x right shift 2 will result in the value 2. So you can check the binary representation of x. So binary representation of x is 1 0 0 0. The bits of the binary representation of x will be shifted towards right by 2 bits. So that's how we are getting the decimal representation of 1 0, which is equivalent to 2. Similarly, you can even apply the left shift operator on a variable or the value. So consider this example, x left shift 2. So this statement indicates that the bits of x are to be shifted towards the left by 2 bits, so which results in the value 32, which is again in the decimal representation. So the operation internally takes place in the binary representation, but the value returned by these shift operators is in the form of decimal representation. So consider this binary representation of x. So you can see the binary representation of x, and after applying the left shift operation, so it results in the integer value 32. The binary representation of x will be shifted towards left by 2 bits in this case. So you can even try shifting by 4 bits. So here you can see, so x left shift 4, so which results in the value 128. So here x value is 8, and when you apply right shift operation by 2 bits, it results in 2, and when you apply left shift operator by 2 bits, it results in the value 32. These left shift and the right shift operators are actually equivalent to the arithmetic operators. Say for example, when you are applying the right shift operation by 2 bits on x, it results in the value 2. So which is equivalent to applying the division by 2 square, that is 4. So x by 4 resulted in a value of 2. So whereas the right shift operation by 2 bits is also equivalent to 2. So that means the right shift operator is equivalent to the division operation on the variable, and you are actually dividing by 2 power the number of bits you are shifting. Here you are shifting by 2 bits. So divide this number by 2 square, that is 4. So here you can see, so this value is resulting a 2 value, whereas the right shift operation by 2 is also resulted in a value of 2. And similarly, the left shift operation is equivalent to the multiplication operation. So whereas here in this case, you are applying the left shift operation by 2 bits, which is equivalent to multiplying the operand x by 2 to the power of number of bits you are shifting. So 2 to the power of number of bits you are shifting is 2, which is equivalent to 4. So x into 4, which is equal to 32. Here you can observe x left shift 2 is 32, whereas x multiplied by 4, which is actually x multiplied by 2 to the power of number of bits you are shifting 2 square. So x into 4, that is 32. That's how the right shift operation is equivalent to the division operation, whereas the left shift operation is equivalent to the multiplication operation. So far in this hands-on session, we have seen various bitwise operators like the bitwise OR operator, bitwise AND, bitwise XOR operators, and moreover we have seen the unary bitwise NOT operator, and in addition we have seen two bitwise shift operators, that is bitwise right shift and the bitwise left shift operators. All these operators can be applied only on integers, they cannot be applied on other type of data. All these operators work on the binary representation of the operands you are providing. That is why these operators are known as a bitwise operators, but the result returned by these operators are in the form of the decimal representation. Now I hope you understand the working of various bitwise operators in Python. Thank you for watching this video.